If we're going to study what nth roots are, then you need to know that first, n is going to be defined to be an integer, and we usually abbreviate that by saying n is an element of the integer set, and z is the symbol for integer set. And we're also going to say that n is going to be greater than or equal to 2. So we need a definition of what an nth root is, and I'll say that a is an nth root of k if and only if, which means this is true if this is true, or vice versa, a raised to the n equals k. So when I look at a problem and I say, hey, 3 squared equals 9, I'm essentially saying my a is 3, my n is 2, and my k is 9. And that would mean that 3 is a, and since n is 2 here, we would say square root of 9. Now I can graph that over here, and what I'm going to do is I'm going to graph y equals x squared. However, I'm going to want to probably change this to maybe a cube or a fourth or a fifth later on. So up here I have n equals 2, and so if I change this to y equals x raised to the n, I'll have a quadratic function whose shape is a parabola. Now, of course, if I shift this to 3, this would be a cubic, this would be a quartic, and so on. So I'm just going to leave it as y equals x squared. And I can type in y equals 9 to represent my height. The 9 crosses here, and you'll see that I have not just one solution at what's going to be negative 3, 9, but I also have another solution at positive 3, 9. But I mentioned the negative 3, 9 first, but I didn't write that over here. And that actually leads us to understand that what we're saying is that since negative 3 squared also can equal 9, yes, my a is negative 3, but everything else is still the same. By our definition up here of what an nth root is, we would also have to say negative 3 is a square root of 9. Now this is going to lead to some problems, because at some point I may want to solve a problem where it would have said x squared equals 9 or 4 or something like this, and I'll go back to x squared equals 9. And I would have to use some kind of function or operation to solve this, which means I really got to be looking at the inverse. So what I'm going to do is I'm going to take my y equals x squared graph, which is right there. I'm going to reflect that over the identity function, which is this line graphed in yellow. You will see that that graph, which let's put in a red color to stand out a little bit, is no longer a function. Because what will happen is that this horizontal line test that I could be applying, when placed or reflected over the identity function, becomes a vertical line, and now definitely seems to be failing the test. And more importantly, it's also telling me that I have two answers. Negative 3 would be one possible answer, and positive 3 would be another one. That's not allowed. Now, let's be clear here. I am not saying that you shouldn't answer x equals 3 and negative 3. What I'm saying is, if we're going to define a function, and we write that function as, let's say, nth root the function, and that's going to be written using a radical symbol with an n in that spot, we're only allowed to get one answer out. And what's going to end up happening is that nth root of 9 is only, in this case, the square root, which we don't even need to write a square in that place. The only answer that's going to be allowed to come back is 3, because that's what functions allow. Now, before we go any further and get into a little bit more detail, this is not the only way to write an nth root. Besides writing an nth root as n with a radical sign, I can, and let's call this for the number k here, I can also take k and write it as 1 over n as an exponent. So if I say k to the 1/nth, I am actually saying the nth root of k. So if I were to say 9 raised to the 1/2, I actually do mean the square root of 9. And unfortunately, because of the rules of functions, I'm only allowed to get one answer out, and that answer happens to be 3. So what we need to do is discuss exactly what it means, or how does one know what the root is. And so we'll move on to the next page. And what I'm going to do this time is I'm actually going to graph y equals the square root of x. It's going to pop up on here. Let's make this object now blue color so you can see it. We'll even make it stand out a little bit more. We'll make it wider. And you'll see that it's choosing the top half. What it is doing for a square root is it's choosing what is called the principal root. And there are rules for this. And the rule says that if n is even, and that's important, the principal root that comes back will always be the positive of the nth root, positive nth root of your answer. So it does not matter that if you had gone 3 squared and take a radical, which would work out to be radical 9, you would get 3 out. The classic in goes 3, out comes 3. If I would have taken negative 3 squared, I would still get radical 9, and I would still get a positive 3. So in goes negative 3, but out comes 3. And for all practical purposes, what we're saying is we are restricting the domain of this graph over here on the side. So the only answer that comes out will be that. Now, if I go to a 4th root, you'll see that the same situation applies. If I go to a 6th root, the same situation applies. If I go to an 8th root, same situation applies. What you should notice, though, is I haven't talked about odd roots. So let's go all the way back to a cube root. If I look at a cube root, let me get rid of this, please, delete, you will see that we don't have the same issues over here. The horizontal line test only crosses one point. In this case, if I wanted to say, let's make this value not 9, but 8, meaning, so first we're talking about n is odd. And down here I'm thinking to myself, okay, when does x cubed equal 8? I'm finding out that my one and only answer is coming up as 2. If I look over here on this particular graph, it only crosses once, and this cube root function is crossing at a height of 2. So I only have one answer to worry about. It literally is x equals 2 for that particular problem. I don't have a negative nth root that I have to ignore or vice versa. But I should realize that I could still have a negative nth root, but that's because I have x cubed equaling negative 8. So what we're going to do is grab this line and we're going to move it down a little bit to the point where we actually have to pick up this graph, move it over to here. Let's grab it some more, bring it down to negative 8. And you're going to see that in this case, I can get that if I put in negative 8, out will come negative 2. So in this situation, x equals negative 2 can come out, but that's because I have this. So in this case, I guess what I'm saying is the cube root of 8 is equal to 2, and the cube root of negative 8 is equal to negative 2. I don't have the same issues as I've had with the evens. Now, back to our squares. Here we go. There's our squares. I'm trying to figure out, let's put that just down here. If I'm going and trying to figure out, hey, when do I have the square root of negative 8? I'm looking at my black graph, and I'm saying, hey, wait a second, it never gets down that low. There is no real answer. And therefore, when I take its inverse, and yes, this is not a function, but if I do look at its y equals square root of x graph, and only look at this piece, again, it never can put in -8. This is a non-real answer. For those familiar with imaginary numbers, this would be a situation where you would pull out a square root of -1 multiplied by the 8, and you're going to be involved with an I times radical 8. I am not going to worry about imaginary numbers, so we're just not going to get all hung up on that. If we run into a square root of -8, you can just simply say it does not exist, or there is no real square root of the number -8.